All right, in Unit 9, we're still dealing with exponential and logarithmic functions, but for this unit, we're going to start solving and graphing them. For this unit, you do need to remember the same properties from day 4 of last unit. So the product property, the quotient property, the power property, the inverse property, and the change of base property. So I just have those here to refresh your memory. We're going to go through 5 examples together, and just like last unit as well, I'm going to have them all mixed up at the try on your own, so you can sit there and pick out which property or how you solve which type of example. So for the first example is when you can get the base of exponentials to match. And one thing that I want to point out, you're actually going to rewrite the bigger base to look like the smaller one. Here, 1/9 is technically smaller than 3, but we don't like dealing with fractions. So that's why I talk about the smallest whole number. So what I'm going to do is I can rewrite 1/9. That's the same as 3 to the negative 2. So instead of writing 1/9 in this equation, I'm going to replace it with 3 to the negative 2 power. So what happens is I can multiply those exponents together. And then this is kind of like our inverse property. Right now I have an exponential base 3 and an exponential base 3. So those actually go away, and I can just write that x minus 5 equals negative 4x. So then I just solve this equation like normal. I bring the x to this side to get negative 5 equals negative 5x. Divide both sides by negative 5, and I'm left with x equals 1. For example 2, so this is where I have two exponentials or an exponential number, and I cannot get 7 and 21 to look alike. So 7, no matter what power I raise it to, will not be 21. So this is where it's kind of like our change of base. So what's going to happen is I'm going to take, since logs are inverses of exponentials, I'm going to put a log on either side. What this helps me with is I can use the power property and bring that negative x down front. And then from here, I actually divide both sides by logs. So this is where it kind of looks like the change of base property. Also, I'm trying to get this x by itself, so it's being multiplied by negative 1 and by log 7. So I'm going to divide it by negative log 7. So once you type that into a calculator and round your answer, you should get negative 1.56 as an answer. For example 3 is the easiest. If you look, I have log base 10 on either side of the equal sign. Just like when the exponentials, the base 3 exponentials canceled out, the same will happen here. If I have log base 10 on either side, they just go away, and I'm left with 15 equals 3x. So if you divide both sides by 3, I'm left with x equals 5. I actually typed this in wrong. This should be log base 5x to the 4th power. So go ahead and make that change in your example. So if you only have one log in a problem and it's just set equal to a number, you're going to use your power property where you bring that power out front. So I have 4 times log base 5 of x equals 8. From here, if I'm trying to get x by itself, I have to get rid of everything outside of it. And the furthest thing from it is this 4. So I'm actually going to divide both sides by 4 to get log base 5 of x equals 2. From here, we're just going to rewrite it. Once I have log set equal to a number, that's when we rewrite it as an exponential. So 5 squared equals x, which means x is 25. All right, the last example uses the product and quotient property. So here I'm subtracting, so that means I need to divide my two answers. So I'm going to combine my logs as 1. The first input goes on top and the second input goes on bottom. Again, I know it looks a little funky, but I have log of an input equals a number. So this is where an exponential will help me solve this problem. So if I have 4 to the first power equals 100 over x minus 1, 4 to the first power is just 4. And now I have a fraction. Most of you might be freaking out, but remember, for the fractions, we just need to multiply everything by the denominators. So that will cancel to leave me with 100. And 4 times x minus 1 is 4x minus 4. So now we need to add 4 to both sides. Divide either side by 4. And you're left with x equals 26. So those are the 5 different types of equations you will solve. So here's the try on your own. At the very least, I want you to pick out what type of example each of these look like. You should try and solve these on your own. You should be able to solve all of these on your own. But at the very least, pick out, this one's example 1. This one looks like example 2. And then this one would be easier to read if you have parentheses there. Good luck.